This video is about the properties of exponents. In this video, I'll review with you the properties of exponents and do some examples using properties of exponents. So I'm assuming you all know what an exponent is. So if I write a number a to the power of n, that means that I'm multiplying a by itself n times. A is the base, and n is the power or the exponent. So if I wrote 4 to the third power, that would mean 4 times 4 times 4, which is 64. I wanted to bring out my calculator here to show you, because to do that last problem, I could have just done 4 times 4 times 4 on my calculator. But the quicker way to do it is to do 4 caret, right here, 3. And you can use this caret to put any exponent in there. So you can do 4 to the third, 4 to the fifth, 4 to the ninth, and it's just kind of a faster way to find the value of a number to an exponent. Alright, so here's a review of the properties of integer exponents. When we multiply exponentials with the same base, we add the exponents. And by the way, these properties that I'll be reviewing in this video are all true when a and b are non-zero real numbers and m and n are integers. You should probably write that down, so I'll say it again. These are all true when a and b are non-zero real numbers and m and n are integers. So when we multiply the same base to a power, we add the powers. When we divide with the same base and different powers, we subtract the exponents. When we have a power to a power, like this, a to the m to the n power, that's the same thing as a to the mn. So when we raise an exponential to a power, we just multiply the exponents. Another property of integer exponents is a number a to the 0 power. Any number to the 0 power is always equal to 1. Now, a cannot be 0. When a is 0 and we raise it to the 0 power, it's not defined. Okay, here are some other properties. If we have a number a to the negative n power, that is the same thing as 1 over a to the n. We can also write it as 1 over a to the n. But really, this is the more popular way or more common way of seeing it. We could also sometimes have two numbers multiplied by each other, like a and b, and we can raise both of those to the n power. If we do that, it's the same thing as a to the n times b to the n. And the last property of integer exponents that I'm going to review with you is if we have a divided by b to the n power, that's the same thing as a to the n over b to the n. So let's do a couple example problems using these properties to simplify expressions with exponents. Alright, so we're no longer in Algebra 1, folks. So we're in Algebra 2, right? So we're going to pick it up a notch. and look at some complicated problems just from the beginning. So the first problem we're going to try to simplify is 3x squared z to the negative 4 all to the negative 3 power. Now we're going to be using a couple of the properties I just reviewed. The first thing I would do, and with these you don't have to do it all in the same order. One of your friends might do things in a different order, but I'll show you one way to approach it. And if you happen to approach it a different way and you get the same answer, that's okay. So when I approach a problem like this, what I do is I like to distribute the power first. So that means I would have 3 to the negative 3 times x to the negative 6 times z to the 12. 2 times negative 3 is negative 6, and that's how I got the negative 6. And negative 4 times negative 3, that's how I got the 12. And that's using that power to power rule. The next thing that I would do is to get rid of these negative exponents, because we always want to have positive exponents when we're simplifying these kinds of expressions. So I would leave z to the 12th where it is. And in the bottom, I would have 3 to the 3rd, because that had to move. It was a negative power. And x to the 6th has to move because it has a negative power. And then my last step would be to do 3 to the 3rd power, which is 27. So I would have z to the 12th on the top, 20 over 27 x to the 6th. And that is my simplified expression. Okay, let's do another one together. And after I do this one, I'll have you try one on your own. So, wait, let me write it all down here. Okay, so say I had this problem. So again, we're going to use a couple different properties here. So again, there's a couple ways to go about approaching this problem, but what I'm going to do is distribute those powers first that are outside of the exponent. So that means I'm going to distribute this squared to here, and this negative 3 to here and here. And so that means that I'm left with, that means that my next step is x to the 4th, because it's power to power, I multiply, y to the negative 6 over x to the 3rd, y to the negative 12. For my next step, I would deal with these x's. Since they're the same base, I can just subtract the exponents. And so I would have x to the 4 minus 3, which is just x. And then with the y's, since they are the same base, I could just subtract negative 6. I could just do negative 6 minus negative 12, which ends up being negative 6 plus 12, and that is just 6. So y doesn't actually have to move at all. It stays in the numerator because negative 6 plus 12 is positive 6. And that is my simplified expression. Okay, so here is a problem for you to try. I want you to pause the video and work on this problem, work on simplifying it, no negative exponents. And once you've done that, press play and check your work and your answer with mine. Okay, welcome back. Check out my work and you should know what the answer is. Okay, that is it for this video. Have a great one and let me know if you have any questions. Thanks.